So let's continue our exploration of R data types. It's actually kind of interesting that in R, functions are actually also treated as objects. It's similar to some other programming languages like Scheme, Lisp, and even more modern versions of Java. They actually have the mode function, which is not one of the modes we've seen before, but there is the concept in R that functions themselves are objects can actually be passed as parameters to other functions. And then there's even the concept of self-evaluation. We can call a function to evaluate the function that you are passing as a parameter. In fact, we'll see this later on a little bit in string processing and some of the solutions where occasionally we might want to use eval to help us do this. Now let's move on to the class of an object. So the class of an object determines what can be done with the object, while the mode indicates how it is stored. So I think more of the mode as the storage mechanism that R uses for the object, whereas the class determines really what you can do to it, the kinds of operations that are legal on the object. Now you can ascertain the class of an object by calling the class function. So for example, if you say class CNL, you get back character, meaning that CNL belongs to the class character. It also happens to have the mode character. And another example would be class mean. Mean is one of the built-in R functions. Of course, what you're going to get back is that it belongs to the class function. Now this affects us when we start doing some processing, particularly when we process data that has categorical data values. So categorical data is one of the most important types of data in R because a lot of statistical processing later on depends on having categories as factors, particularly if you're doing ANOVA or some other type of regression testing, then you need factors. And various R functions and hypothesis testing functions employ factors. Now categorical data can be stored as numeric, character, or the special factor object mode. Now storing categorical values as factor uses less storage, and then you can use that also for statistical analysis. Like I said, a lot of the statistical functions for doing regression, modeling, ANOVA testing, other types of hypothesis testing require that the categorical values be stored as a factor object. You can determine if a function is, or if a particular variable is a factor by saying is factor, and you can convert from one to the other by using the as factor function that allows you to convert a character set or a set of labels to factors. Here's an example of that. So suppose I have the vector semesters made up of fall, spring, and summer. So if I determine the mode or inspect the mode of semesters, I get back character, which is what we expect. But then I can say semester.factor, basically create a new variable called semester.factor, that to which I assign the result of as.factor of semesters. So I'm basically passing semesters to as.factor, so that converts my vector of strings into a factor object. So now if I say mode of semester.factor, I get back numeric. And that's because internally it's actually stored as numbers, which is the reason why the storage of factors is a lot more efficient than the storage of simple strings. Imagine that you had a database with a few 100,000 courses from various universities or educational institutions, and you want to figure out when those courses are being offered. Well, if for every course you store fall, spring, or summer, well, you would have to store on average, fall is 4 letters, spring is 6 letters, and summer is 6 letters as well. So on average you're going to store about 5 letters. Well, each letter is a single byte, so that's 8 bits, which means if you do that, it's 5 times 8 bits. 5 times 8 bytes, it's a 5-byte storage. Well, if you store it as a number, it's 32 bits. 32 bits is 4 bytes. So that basically means you're saving on average, just for this alone, 1 byte of storage, which may not seem like a lot on a small data set, but if you have hundreds of thousands and millions of records, it makes a significant difference. It also makes the statistical processing a lot faster because computers operate a lot faster on numbers than they operate on string values. So again, to continue this, if I then, of course, print out semester.factor, watch what I get. I get right here, I'm printing it out, I get fall, spring, summer, and I get what's called levels, fall, spring, summer, because that's actually the internal representation. So this is, I believe it's 1, 2, and 3. It may be 0, 1, and 2. I don't remember. And then, of course, you can say class semester.factor, and that returns you back that it's the factor class. So far we've created a lot of vectors, but I don't really talk much about the vector data type itself. We introduced it in a very high level, very tangential way in a previous module, but we never really got into explaining exactly what a vector is. So a vector is any single value or any collection of values, either numeric, logical, or character. So if you assign a single value to a variable, that's actually considered to be a vector of one element. Now, you can create a vector by either assigning, like I said, a number to it, or text, or logical true or false, or you can use the C function, the concatenate function, to create a vector. So if, for example, in this case right here, we say num.vec, so we're creating a vector called num.vec, as the result of the concatenation of the values 1, 3, 5, 8, 13, 21, which is the first few numbers of the Fibonacci series. And then I can, of course, always print out a vector by simply saying num.vec, the variable by itself, and I get the result of it. The mode of it, of course, is numeric. The class also is numeric. And if you look at whether it's a vector or not, if I say is.vector, num.vec, I get back, of course, true. So that is one way I can inspect whether an object is a vector and may be usable in an environment where you expect a vector as input, let's say to a function. Now we can actually create mixed mode vectors. So a vector with numeric and character values is going to be converted, of course, to a character vector. So while you might think that you're going to get a mixed mode vector, the actual type conversion rules of R kick in. And remember, anytime you have mixed mode where you mix numeric mode with character mode, everything gets converted to character mode. So right here we say mix.vec as the concatenation of 1, 3, 5 and the string 13. What you actually end up with is 3 characters, character 1, character 3, character 5, actually 4 characters, and character 8, plus the string 13. And the mode of that, of course, becomes character, but it's still a vector. But you would no longer be able to do any kind of operations mixing that vector with a vector of type numeric. Now you can combine vectors by using C. So if, let's say, we have mix.vec, which is the vector of 5 character strings, and we've got the vector num.vec with 6 numbers. If I then say new.vec as the concatenation of the numeric vector and the mixed vector, again, I have mixed mode, so R is going to do some conversion. So it's actually going to, remember, convert, if you have a mixed mode of numbers and characters, everything to character. So that's how my entire vector now is a character vector. And all of the original num.vec elements, these ones right here, got converted to characters because of mix.vec. So far, we've created unnamed vectors, which means the different vector elements were not really named and could only be accessed through their position within the vector. But you can actually create a named vector. So here's an example. We say named.vec is a concatenation of 3 vector elements, fall, spring, and summer. But I'm naming them as S1, S2, and S3, which means I can actually access them individually with name.vec $S1, name.vec $S2, which might be something a bit more convenient than just simply accessing it positionally. Now here's an example of assigning a single value, so-called scalars, to a variable, which, again, like I said, single values are in fact vectors with a single element. So if you say x gets assigned the value 99, it's of mode numeric, of course, it's of class numeric. But if I then say is.vector of x, I actually get true. You wouldn't think that that a single value would be a vector, but indeed in R it is considered to be a vector. Now you can convert between various different modes, and we've seen a couple of different mode conversions already. But mode conversion is generally done with as, dot, and then some kind of a name. So there's a whole collection of functions for conversions like as.numeric, as.logical, as character, as data frame, and as list. So basically they convert whatever you pass to a number, to a logical value, to a character, to a data frame, and to a list. Assuming, of course, the conversion can be done. If it can't be done, you're going to get an error message. There's a couple of simple examples on doing a conversion. So this example converts a vector of numeric values into a vector of logical values. So now, of course, you got to understand how R treats logical values. And we said before that true is a 1 and false is a 0. It's actually not quite correct. In fact, R treats logical with numeric values as logicals, similar to other programming languages like C and C++ and Java. So actually, any non-zero value is considered to be true, and false is only the value 0. So for example, if I have the vector with the concatenation function C minus 99, 0, 99, of course I have 3 numeric elements. If I then say as logical nvec and assign it to a logical vector lvec, again, if you print that nvec, I get 3 numbers. But if I not print that lvec, I get true, false, true, because minus 99 is non-zero, so that's assumed to be true, 0 is false, and 99 is again true. Doesn't matter if it's a positive or negative number, as long as it's non-zero. And if you look at the mode of L.vec, it is logical, because it made the conversion from the numeric vector to the logical vector. This is similar to what you might do in other programming languages with casting. Now, when you do conversions through the as functions, you may sometimes not be successful in converting certain elements. So for example, right here, if I say as.numeric of charvec, and charvec contains 1, 3, the string 5, 7, it can only convert 1, 3, and 7, and 5 it can't convert because it doesn't really interpret the letters. So it's then going to introduce NA as a missing element. It says I can't do anything with it, so I'm going to introduce the not available element. So that concludes this lesson. Any questions you have, please post them to the discussion board.